All right, we're starting. Hello and welcome back to Calculus 1. This is the last section for today. We are going to be working with integrals. This is a series of useful formulas that will sporadically help here and there to calculate things faster. And these formulas will be used much more in the later mathematics to cut out some really crazy calculations. Right now, you might see them here and there and exploit, them here and there. So they're cool to know. We are going to start with integrals of even and odd functions, which utilizes symmetry to cut down our calculations. So let's take a look with the integrals of even and odd functions. So first, even function is defined as f of negative x is the same as f of x, and odd function is defined as f of negative x is negative f of x. So these are the definitions for even and odd function, and you can use this to test. So say you have a function that says, as the example, f of x is equal to x cubed minus 5x. So you try to see if it's even. So negative x cubed minus 5 negative x. So you are plugging in negative x. And then you compute that and you get minus x cubed plus 5x. And that is supposed to be the same as the original function. But you see that the signs are not the same. So is it even? No. This is your pre-calc 1. So you try odd. If odd doesn't work, then it's neither. That's possible as well. So now for the odd function, you need to have that the f of negative x is equal to negative f of x, which actually happens in this case. So negative x cubed minus 5 minus x is negative x cubed plus 5x. But look, if you kick minus outside, you get x cubed minus 5x, which is negative f of x. So you just proved that f of negative x, which is this thing above, is the same as minus f of x. So yes, it's odd. So, if you know these properties and know how to check these properties, then you can say following. If f is even, then the integral from negative a to positive a of f of x dx is equal to two integrals 0 to a f of x dx. This helps because it's much easier to multiply by 2 than to plug in negative value into entire function and compute over how many of these. It's much easier to compute with 0. So if f is even, you are allowed to do that. And if f is odd, so odd function on the symmetric interval will immediately give you 0. And you had that sign as the example for that one. So for the bottom one, integral negative pi to pi for sine x dx is immediately going to be 0 because of the negative positive, they cancel out. So if you have odd function, you can also use x cubed, you can use, well, whatever is odd. It will go through this. there are other properties that are really cool to know. I'm going to put these ones in red because they are really good. Integral a to a of f of x dx is equal to 0. Can anyone tell me why? Exactly, there is no width. Dx is 0. You remember the definition? The long way definition? B minus a over n? Well, if both of these are a minus a, right? Then you're multiplying times 0. This is 0, so the whole thing dies. Awesome. Another cool feature that you will actually use a lot in Calc 2 is that if you don't like the order of the limits, right? If you, we will see this eventually also in 5.5, but not too much until you really get into Calc 2, and then you will see it much more frequent. You end up, after you're doing use substitution in 5.5, or other substitutions later, you end up with a larger number on the bottom and the smaller number on top, right? So you can fix that by putting the minus in front and then switching the limits. So you can switch those and put the minus sign. If I look for about 6 seconds, I should be able to find example of this in my Calc 2 class very quickly, because it happens. And then here is another cool one, which is the one that allows you to split over multiple integrals, so you can do the areas. So if a is less equal than c less equal than b, so c is somewhere in between a and b, then integral a b f of x dx is equal to integral a c f of x dx plus cb f of x dx. So this tells us that we can interrupt integral at any point in between. Now, for that one, proof is very easy because you can draw a pretty picture. You see, if you draw some arbitrary function f of x and you have a to b and you pick c somewhere, well, area 1 plus area 2 is still overall area. It doesn't matter where between a and b you pick to cut. When you compute those two integrals, they will add up to the same integral if you did it from a to all the way to b. This one is going to be crucial. So out of all formulas, this one is extremely important because you will have to deal with improper integrals. You will have to deal with a lot of other stuff in Calc 2. So the two formulas you see on the board now, those are the ones that are most frequent. And the last formula that we're talking about here is the average formula, which ends the lecture and ends the stuff for today. Yes?
What about the transitive property?
We can add that too. So average. Average formula. So average value of the function is 1 over b minus a integral a b f of x dx. This is on your project. So let's compute the problem. Find the average value of f of x equals e to the 2x on 0 to ln2. So plug it in and see what happens. All right, all set? Apparently you are.
Yes, of course.
So the average value will be 1 over ln 2 minus 0, integral 0 to ln 2 of e to the 2x dx, which is 1 over ln 2 e to the 2x over 2 computed from 0 to ln 2, which is 1 over ln 2. And now what do we do? Compute it. E 2 ln 2 over 2 minus e to the 0 over 2. Just interested in how many of you skipped on computing 0. You have to in this case, because e to the 0 is 1. So you have the half surviving there. Now this 2 is going to go in as the exponent, so it's ln 4. So this becomes 4 over 2 minus 1/2. So the whole thing is 3 over 2 ln 2. So the 2 in front of ln goes in as the exponent. 2 squared is 4. E and ln cancel, so 4 over 2. And then you have 4 halves minus 1/2 is 3 halves. And that's it. Cool? Cool. Now I just want to make Eli happy with the linear formula. So if you have an integral a to b of, I don't know, constant a f of x dx, x plus b g of x, all of that dx, you can kick the formula constant out, integral f of x dx plus constant b kicked outside, g of x dx. All of these are from a to b. And you can also have that hold if it's a minus. Just like for derivatives, you cannot deal with products and quotients, right? There are special ways in which you have to. So you can do the separate integrals for addition and subtraction. You do each one independent. But if you have a function times a function, you cannot do the separate integrals. That doesn't work. You have methods that we learn in Calc 2, like integration by parts. For quotients, in certain cases, we either use partial fraction decomposition or trigonometric substitution. So there are ways and methods in Calculus 2 that are learned for you to deal with products of functions. We are going to see some simpler products dealt with the U substitution next Saturday. So be careful about that. All right, so that's it for today. I will see you all next Saturday.